So today we are going to be talking about how to graph the square root function. So we have y equals the square root of x, and that's going to be the parent function for this style of graph. So let's go ahead and take some table of values. And I'm going to pick some points that when I go to square root x, I get a nice pretty y, and that way they're just easier to plot. So I'm going to list all the perfect squares. Now I have to keep in mind that this x, actually not just the x, but anything inside the radical, so anything inside the radical has to be greater than or equal to 0 because I cannot take the square root of a negative. So that means that x has to be greater than or equal to 0, and that's actually our domain. And we'll see what type of values we get for the range. So I'm going to list all my perfect squares, starting with 0, 1, 4, 9, and we could go up to 16. And if I square root 0, then I get 0. If I square root 1, I would normally get plus and minus 1. We're only going to take the positive for right now, and I'll show you why in just a minute when we go to graph it. Square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. So when we go to graph this, so we go 0, 0, 1, 1, 2, 3, 4, square rooted is 2, 5, 6, 7, 8, 9, square rooted is 3. And I'm actually just not going to plot that one, even though I could. So, okay. So the reason we can't have the negative is because this is considered a function. Okay, now functions, remember, they have to pass the vertical line test, meaning that for every x that I plug in, I only get one y value. So if I plug in 1 and I square root and I get both positive 1 and negative 1, well, this does not pass my vertical line test anymore. Same for 4. If I square root 4 and I get both positive 2 and negative 2, then I would have a point down here, and that would not pass my vertical line test anymore. So that's why we only do the positives. So we talked about our domain, so let's go ahead and do our range. Okay, and range is y values. So all of these y values here, well, they start at 0 and they go up, which means they're not going to be less than that, so they'll be greater than and including, so or equal to 0. All right, so we're going to do 3 graphs, and we're just going to graph them, and then we're going to look at the domain and range of each of them. So we have y equals the square root of x plus 5. Okay, so what we want to do when we're looking at here is I always like to say, well, we want this value to be a perfect square so that when I square root it, it gives me a nice pretty number. So my perfect squares are 0, 1, 4, 9, 16. We could continue on, but those are the ones I normally go with. So what value of x would make this expression 0? Well, x would have to be negative 5. So if I plug in negative 5 plus 5, I get 0, and the square root of 0 is 0. So now we're going to do that again, and this time I want it to be the square root of 1. So what number of x could plus 5 would be 1? Well, that would be negative 4. So negative 4 plus 5 gives me square root of 1, which is just 1. Okay, so now I'm going to change that 1, and I want that to become the square root of 4 because that would give me 2. So negative 3 plus 5 would give me square root of 4. So that would be negative 3x, and then it goes to 2. So I'm trying to pick values of x that would give me a perfect square on the inside. My next big perfect square is 9. So that means that we need this to be 4. So 4 plus 5 would give me 9. Square root of 9 is 3. Okay, let's go ahead and graph those. So x starts at starts at negative 5 and it goes to positive 4. So let's get a nice long line and we'll put our y-axis right in the middle-ish. So negative 1, 2, 3, 4, 5, negative 4, negative 3, and then we go up to 1, 2, 3, 4. So this one, negative 5 is on 0. Negative 4 is at 1. I think we did negative 3 wrong. Let's check that one because that is right here and that would make a straight line. So let's see where our mistake was. So we got 0, 1, and 4. So if this would equal square root of 4, x would have to be negative 1, not negative 3. I messed up. Okay, so that would fix this. So if we go to negative 1 instead of negative 3, negative 1 is 2. Okay, 4 gives us 3. So now I have that same general shape again. And if you turn your graph sideways, here, let's see if we can do this. It kind of actually looks like a parabola. So that's what happens when we take the square root, is it flips it. Okay, so now let's go ahead and look at the domain and the range. Well, let's remember the domain means that whatever's on the inside, so x plus 5, has to be greater than or equal to 0. So I could solve by subtracting 5 and say that x is greater than or equal to negative 5. Well, that actually confirms the fact that we start at negative 5 and we go to the right. So my domain is x is greater than or equal to negative 5. Our range is actually going to be the exact same as above because we start at 0 and we go up for the y values. So our range is y is greater than or equal to 0. All right, so our next example, we're going to have y equals the square root of x plus 3. And actually, let's go ahead and say, how do we compare this to our parent function? So if I put our parent function here, let's see. I'm just going to draw the first couple ones. Then this is a shift left 5. And we're going to see that that 5 here caused that. All right, so let's go ahead and make our table of values for this one. Okay, so since the radical only has the square root of x, then I can actually just go ahead and use my perfect squares because there's nothing with x. So I can do 0, 1, 4, 9. I could do 16 if I want. Square root of 0 is 0, plus 3 is 3. Okay, square root of 1 is also 1, plus 3 is 4. Square root of 4 is 2, plus 3 is 5. Square root of 9 is 3, plus 3 is 6. Okay, so now let's look. So our x's are 0, 1, 4, 9. And my y values start at 3 and they keep going up. So I'm going to draw my graph a little bit taller this time. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 0 is at 1, 2, 3. 1 is at 4. 4 is at 5. And 9 is at 6. So my graph does this. So let's talk about our domain and our range. So our domain, our x, and range is y. So the domain, all of our values that we can plug in has to be greater than or equal to 0. So that just means that x is greater than or equal to 0. Our range, they start at 3 and they go up. So that means that y is greater than or equal to 3. And if we compare this to our parent function, then we can see that it has been shifted up 3. And again, that 3, this one is outside the radical, did a vertical shift. The other one was inside and it did a horizontal shift. All right, so let's do one more. So we have y equals negative square root of x plus 2 minus 1. Actually, let's do plus 1. Okay. So if we have our x and our y, okay, again, I want the part that's inside the radical to be perfect squares so that it makes my life a lot easier. So we want them to be 0, 1, 4, 9. So if we make x negative 2, then that will go to 0. If we make x negative 1 plus 2, that goes to 1. And then if we make x 2, that would make 2 plus 2 is 4. And then if we make x, let's see, 7 plus 2 is 9. Okay, so those are going to be my x values. Now we're going to evaluate this. So we know that if we plug in negative 2, then we get square root of 0. But I still have this negative out front. And that may not matter right now because it's 0. But it will matter in just a minute. So negative square root of negative 1 plus 2 is 1 plus 1. So this is square root of 1 is 1, but I still have that negative out front plus 1. And that actually goes to 0. So we still have the negative. 2 plus 2 is 4. So negative square root of 4 is 2. And then plus 1, that's now negative 1. Okay. 7 plus 2 is 9. Square root of 9 is 3. Negative 3 plus 1 is negative 2. So my x values started at negative 2. My y values started at 1, and they're going down. So let's draw our graph like this. All right, so we start at negative 2, and y value is 1. If we go to negative 1, then we get 0. Then we go to 2, and we get negative 1. 3, 4, 5, 6, 7. And then we have negative 2. So now I have a graph that looks like this. So we changed that a lot. Our parent function would be like this, 2, 3, 4, square rooted, 7, 8, 9. There we go. So our parent function looks like this. So we did 3 things to this one. We shifted it from this point to this point. We went left 2 and up 1. So left 2, up 1, and then we also reflected it. Okay, so left 2 comes from here, up 1 comes from here, and the reflection comes from that negative. So let's go ahead and compare. Oh, let's do our domain and range. So our domain, range. Oops. Okay, so our domain, x plus 2 has to be greater than or equal to 0. So x is greater than or equal to negative 2, and that's confirmed within the graph. So x is greater than or equal to negative 2. For our range, our highest y value is 1, so it's going to be y. Instead of being greater than or equal to 1, it's actually less than or equal to 1 because it's going down from there. All right, so we've got a few transformations that we did. We shifted it left and right and up and down, and then we also reflected it. So there's a few things. So let's say we have y equals the square root of x, and then I'm going to put a few numbers here, here, and here, and we're just going to highlight them. So there's a few types of transformations that we could do. Okay, so this one. This could stretch it, shrink it, or reflect it. And just like with the quadratic functions, reflected it means it's a negative number. And then stretching it means the absolute value of the number is greater than 1 because we're getting bigger. Shrinking would be the absolute value of that number is less than 1. Okay, so we're taking the absolute value of that number. For this one, see how it's x minus? So this is going to be our horizontal shift. And notice that it is inside the radical. It's always inside the radical. And it's going to go the opposite direction because it's negative. Okay, so if we're subtracting a negative, then it'll be positive. Which means this one is our vertical shift. And it is the same direction as the sine. Okay, that's it for today. Let me know what questions you have when you come to class.